dang it, forgot the recording. Anyway. Well, one application we can use these graphs for is if we remember the way back in equation when we had absolute value equation. Okay, we can use the graph to solve them. Okay, so example, so we're looking on page 37. Okay, we can use these graphs to solve inequalities. So, the absolute value of x equals 4. So, equation-wise, what's my two possible solution? Plus or minus 4. Okay, let's draw the graph of the absolute value of x. So, we treat it as y is the absolute value of x. And so, y1, y2 is 4. So, either side of the equal signs, we set y equals. Okay, we sketch those two graphs pretty accurately. And pretty, of course. Okay, don't forget on your axes that you're putting arrows on all four ends, which I haven't done very well today. That one I did. Arrows at the end of your functions. So, alright, so the two intersection points in this particular example. Okay, what are the x values? Looking at the graph. So therefore, x equals possible minus 4. Okay, so of course this one can solve it algebraically, which is doing a nice simple example to start with, to get the concept, and then move on to something a bit more difficult. Right. F, the absolute value of x plus 2 is greater than 1. So yes, we've solved these sort of things in equation. Yes, way. Well, I'm going to go back and revise some things. Right, so the absolute value of x plus 2, where does that intercept the x-axis? Shift to the left 2 places in the opposite direction of the constant. Okay, otherwise you need to work on to use your intercept skills. Okay, for either side of the inequality, we set y equals for both sides, and then we graph the functions on both sides. So we've got the horizontal line at 1 to represent this side, and then the absolute value of x plus 2 to represent that side. Okay. So what is the intercept of the y-axis? Looking at the graph of the absolute value one. Really? The intercept of the absolute value on the absolute value graph on the y-axis. Okay, so the original question, the absolute value of x plus 2, what point of your graph is the absolute value of x plus 2 greater than 1? Pardon? Good. Above y equals 1. Everything that way. Up here. So, we need to work out what the x values are. Who thinks they could tell me looking at the graph?
-1, -2.
Excellent. Okay, because you've got the y value is 1, okay, and we know we've got the 45 slant, like your isosceles triangle, with the right angle in it as well. Okay, therefore we must be shifting 1 unit on either side to get to there. Alright, so we now need to write our final solution. So using all those concepts put together, what is my final solution going to be? Okay, from this value here, what value of x from -3 is the absolute value function greater than the horizontal line? If we go to the right, the left, sorry, of -3, this graph will always be greater than the horizontal line. Okay, so x must be less than -3. For any value of x less than -3, the absolute value graph is going to be greater than that horizontal line graph. Now looking at 1. Okay, if I go to the right of looking at -1. Now we go to the right of -1. Right, the absolute value graph will be higher, greater, more than, right, the value of the horizontal line. Okay, so yes, in equation we have solved this to get that. Okay, but graphically we can use that as well. Alright, any question? Alright, we'll move on to the next one. Alright, so this is exercise 5.6. Okay, so we're now looking at a first type of graph that's not a function. Okay, the hyperbola. Right, so hyperbola is in the form y equals c over x, or rearranging, x, y is equal to that constant number. Okay, so C is representing a constant number, typically 1, okay, but not always. Right, so if I just multiply, cross multiply the denominator, I'll get that. Okay, so all hyperbolas have a point where the graph breaks into two separate pieces. Okay, at the point there are two lines that the curve gets closer to but never touch it. Okay, these imaginary lines are what called asymptotes. Okay, we're going to look at that in a bit more detail now, and Rob and Kyle will look at that in more detail tomorrow morning. Okay, so information on the domain and range can be used to determine the location of the asymptotes. Right. Sketch following state, domain and range. A. So the one you would hopefully typically seen before, y equals 1 on x. So we could go through a table of values and plot points as we go through the table of value, and there's a certain number that when we put it into the function, we're going to get a mathematical error. What is that number? Well, what value x is going to return a mathematical error? 0, because we cannot divide by 0. Okay? Right, so you can justify this to yourself in your own time if you don't believe me. Okay? Alright, so in the first and third quadrant for a positive numerator. Okay, so we've got the curves approaching but never crossing the respective axes. Alright. So, we cannot have the x value as 0. Alright, we'll say it again. We cannot have the x value equals 0 because when we substitute it into the function, it's going to return an error in there. So, if I were to graph the line x equals 0, okay, that will be your asymptote. Okay, so it's going to be a line that crosses the x-axis at 0. Or in other words, it is your y-axis. So on either end of the arrows that you've drawn on the y-axis, we have an asymptote. Okay, asymptotes are typically dotted lines at the value where x equals 0, and the graph itself will approach but never crosses that vertical line. Okay, so as we get closer and closer to 0 from this direction, we're going to get a very large negative number. And as we get closer and closer to 0 from the positive direction, this is talking about your limits on yesterday, we get very, very large, get a very, very large y value. Okay, and that's why the curve acts as it does. So domain. What restrictions do I have on my x values?
X can't be 0.
Okay, so x is an element of R of the real number system, such that x cannot be 0. What's the one y value that I'm not going to have as part of that graph? Yeah. Okay, because I can't have an x equals 0, and there's no way I can get my y equals 0. Okay, so the way to work it out, the original function, y is 1 on x. You swap your x's and y's over, and then you read that from the range. What values can y not equal?
0.
Okay, so the range, y is an element of the real number system such that y is also not equal to 0. So that line, y equals 0, is also an asymptote. Okay, so it crosses the y-axis at 0. So on either end of this one, just extend it a bit with some dotted lines. Alright, so the curve cannot cross that line. That line is called an asymptote. Parts of your graph where the graph will approach but never cross. Okay, does everyone understand the concept of asymptotes? Somewhat? That's another one, so we won't illustrate it. Okay, B, y, 1 on x plus 2. Okay, so you are adding a constant number within a function. So they're going to have a horizontal shift somewhere. So we cannot divide by 0 here because we cannot have, we have a denominator of 0, so we cannot divide by 0 because it won't give us a mathematically correct statement. Okay, so we need to first work out where the asymptotes are. Alright, and the way to work that out is we write what's in the denominator and show that it's not equal to 0, and the value for x, that will be that I can't have a 0 in that equation. So we are restricted to the value of x equals -2. We cannot have that value as part of our function. So at -2, there is a asymptote. Okay, so that's going to be the detail on your graph that the graph cannot cross. Okay, and you can think of the asymptote as the axis in the original question. Okay, so the graph's going to go getting closer and closer, but never crossing. So, you think what?
That's what I guessed it would look like.
Where gets what?
That's what I guessed it would look like.
Yep, good. Okay, so unlike the original function, there is a point where it crosses the y-axis. Okay, so let's calculate that value, please. Intercepts the y-axis, how do we calculate that? Value for y? X is 0. So y-intercept. So y is going to be 1 over 0 plus 2. Come back to that point later. Right, the domain. Are there any restrictions on the x values?
It's not equal to.
Yep. So x is an element of the real number system such that it cannot equal the value at the asymptote. What about the range? So?
Y can't equal 0.
And that's what I was scribbling on the board to try and work out a mathematical reason to explain that, but I'll have to work on that and think about that, and I'll let you know next lesson. Right, so we'll finish these up tomorrow, then start on circles and semicircle.